Hello, students. I'm quite excited because we finally get to do this. Very simple thing, x equals 3. What did I just do? It's called assignment. It's when you take something, an object, and you give it a variable name. In this case, I gave 3 the variable name x. Now, whenever I refer to x, I get 3. I can do things like x squared, and I get 9. So wherever I place an x, Python places the object 3. Okay. So this is something that we've been waiting for. We haven't needed it yet because comprehensions are so powerful. They're basically like writing mini programs that allow us to get straight to the answer without having to refer to things. Though technically we are sort of using some type of assignment with the counters inside our comprehensions when we say the list of I for I in range 3. Well, technically we are allowing 0, 1, and 2 to be set to I, each one at a time. So that is a form of assignment, but now we're actually doing assignment outside of a comprehension. And you'll notice that we used this symbol for the first time. It's not a double equal sign, it is a single equal sign. And this is the reason why Python uses 2 equals for checking equality. It's because it wanted to reserve the 1 equal sign for assignment. So, how does assignment work? Well, it takes the object on the right and it assigns it to the thing on the left. So, for instance, if I wanted to do y equals 5 plus 6, it took that 5 plus 6, it computed it because that's what it needs to do, and then it assigned it the name y. And if I ask what y is, and now I can play around y plus x and get the answer to that as well. Note that what Python does is it calculates whatever object is on the right, and it assigns it to the name on the left. So if I were to do something like this, I get an error. Python clearly it tells me that it does not want me to assign whatever x is to 3. I'm not going to go too much into the word literal. Literals are things like the number 3, or true, or false. There's strings when we get there, but there are things that Python absolutely will not allow you to write over, which is good sometimes. We already know that Python does allow you to write over things like the len function, right? Both when you're dealing with making your own functions, right? You can actually make a function, call it len, and accidentally overwrite the built-in len. You can actually do the same thing as a variable name here. For instance, I don't want to do this, it's a bad habit, but if I wanted to do len equals 3, let's just go for it. It allowed us to do it. And now if I do len plus x, never do this, ever. I'm just doing it to show you the danger. So now, but if I do this, I now get an error because we assigned len the number 3, which we are never supposed to do. I did it here so that you never do it again. Don't do that. Okay. We can rewrite over variables though. Like, let's say I do x equals 4, and then I do x equals 5, and I ask it what x is. X is now 5. As a matter of fact, we can actually include x here on the right. So let's try to think about what this is going to do here. I have x is equal to x plus 1. So it's going to compute the object on the right. That's x plus 1. X is 5. It gets 6. Then it stores that as the variable name on the left. At that point, it's now overwriting x, and now I'm going to get 6 for x because I computed the object on the right, which turned out to be 6, and then I used that, I overwrote the x. We can assign names to not just integers, we can assign names to the other data types we've studied so far. So for example, I could have x equal true, and then I could say, let's do y equals false, so I can actually give an example, and then I could say, all xy, that's going to be false because not all of those is true. But if I were to say all xx, that's going to be true. And if I were to do any xy, that's also going to be true because y is true. So we can store booleans, we can store sets. Let's say we want to call, I like capital letters for sets from math, so let's do A equals 1, 2, 3, and B equals 3, 4, 5. And if I wanted to do, say, A, oh, by the way, if I do this, it is case sensitive. So we just never define A. Python gives us a very clear error. It says, hey, the error is in the name. What's the error? Exactly tells us what it is. The name A is not defined. So very clear error message there. We can do intersection with the and sign. Now, instead of writing what the sets are, we could just say, hey, A and B. That's going to give me the things that are in A and B. And that's just the number 3 because we have 1, 2, 3, and 3, 4, 5. And for union, we can do that. There's even a set minus A with none of the elements in B as well. We can do this for lists. Let's do L1 equals 1, 2, 3, 4. And let's let L2 equals 3, 4, 5, 6. And now I do L1 plus L2. And I get this. So basically any of the data types that we have, we can give them names. As a matter of fact, we can give names to functions. I mean, you might say functions already have names. Yes, but let's say I wanted to define, I don't know, add 1. And I get lazy. I don't feel like typing out add 1 because that's too much work for me. So what I could do is I could just say AO equals add 1, and then boom. So basically in Python, everything's an object, and with assignment, we can now assign a variable name to whatever object we like.